Hi there, this is Prathamesh, and in this session, we'll learn more about CDNs, also known as Content Delivery Networks. Before we try to understand what CDN is, let's try to understand what happens when you try to stream an animated movie over streaming apps such as Netflix, Hulu, etc. Let's say you're designing a new streaming platform such as Netflix, Disney, and Hulu for animated movies. Let's assume you store these movies on a server, and let's assume the server is located in the US. Let's assume one of our users is located in Asia and is trying to stream this movie on their local laptop. This user is frustrated because it's taking them a long time to load this movie on their laptop. I'm sure you must have been in a similar scenario. Well, the question is, how do you solve this problem? We can solve this problem using content delivery network. Let's assume you have connected your server to a CDN network. Typically, a CDN network consists of numerous servers that are located in different regions across the world. Now, when you try to request a movie from a central server, the central server will track your location using your IP address and will redirect you to a CDN server that is located close to your physical location. You will then be able to happily stream this movie with minimal latency. Thus, CDN allows you to reduce latency of your system by ensuring your static assets such as images, videos, and files are located close to end users. This greatly improves the performance of your application. This is what a typical CDN integration looks like. Typically, you will host your application on a web server. Let's call it a central server. Let's say the central server is located in the US. You will connect this central server to a CDN network typically provided by Google Cloud, Akamai, Amazon CloudFront, or Cloudflare. Once your central server is connected to these CDN networks, you will be able to keep a copy of your static assets such as videos, images, and files on these CDN servers. Thus, your users will be connected to the CDN server that is located close to their physical location, and hence they'll be able to access corresponding data with minimal latency. Now let's take a look at different types of CDN algorithms. There are two basic types of CDN algorithms, push and pull. CDN algorithms decide how frequently you are going to transfer your data, that is movies, images, and files from your central server to your CDN servers. Let's try to understand how a push type of CDN works. In this case, the central servers will push proactively the data to CDN servers at a fixed amount of interval, let's say 1 hour, 5 hours, etc. Advantage of this type of algorithm is that this will ensure the data that is located in the CDN servers is the latest and the greatest data and is frequently synced with the core servers. Thus, this algorithm improves your application performance and customer experience. The disadvantage of using this algorithm is that this service comes at a higher price. Now let's take a look at the second type of algorithm, which is known as pull CDN. In case of pull type of algorithm, the CDN servers will request the data from the central server only if the data that's requested by the end user is not available to the CDN server. Meaning, if a user tries to access the data and that's not available on the CDN server, that's when the CDN server will reactively try to access the data from the central server. The advantage of this type of algorithm is that this service is relatively cheap compared to pull service, but can introduce delay and thus impact customer experience. So, how does one choose the type of CDN algorithm and service? You would always want to check the price of CDN push and pull service offered by different vendors and make a choice based on your budget and requirements. System design is all about trade offs, and while choosing an element, you'll always have to make a trade off. Now, let's summarize what we have learned so far in this section. First, we learned CDN allows you to reduce latency associated with your applications by ensuring the data is stored close to the end user. This also reduces the burden on your central database servers since Users are not trying to fetch the data from the central database servers, but they are always connected to the CDN servers close to their physical location. Secondly, you will learn there are different types of data that can be stored on CDN servers, such as video files, audio files, images, and static assets such as your website logo. We also learn the pros and cons of using push versus pull type of CDN service. There are different types of CDN providers that are available today, and some of those common ones are as follows: Amazon CloudFront, Google CDN, Cloudflare, etc. You must be wondering how Netflix implemented a CDN service to distribute movies and TV shows. Let's take a look at that. So Netflix implemented its own CDN service architecture, and it's known as Netflix Open Connect. Netflix started this initiative in 2012. In 2011, as a response to the ever-increasing scale of Netflix streaming, Netflix wanted to proactively store its content close to its end users and provide a better performance to its users. In this initiative, Netflix works with different ISPs, internet service providers, and continuously optimizes its Open Connect architecture. For more information, please access the link listed in this slide and you will learn Netflix's way of implementing and scaling a content delivery network, also known as CDN. That's it for this session. Hope you enjoyed this session. I'll see you in the next session. Stay tuned.